Hello and welcome to this Medic Mind tutorial where today we're going to be focusing on section 1 of the BMAT, and in particular spatial reasoning. My name's George and I'll be taking you through today's lesson. So let's begin. So there are two lesson objectives of today. First, we want to help you to be able to visualize spatial patterns and in particular spot those patterns to be able to work with the question. And second, I'm going to be sharing with you a host of top tips to help you answer these questions quickly and efficiently. So let's dive in with our first example. Pause the video now and have a go. Okay, let's go through this one together. So with these questions, spatial reasoning, it's important that you read the information that's there. This is because when we're doing spatial reasoning, the major skill is rotating, reflecting, and repeating things within your head. So actually there's not that much information, but what is there tends to be vital rules as to how we go about rotating, reflecting, and repeating. So in that sense, we read the passage and we see that actually there's 30 black squares in this whole set. So the first thing we should do, given that the answer options have a mix of 4 and 3 black squares, is to add up how many there are existing in the example given. When we do that, we find there's 26, and that means that there's 4 black squares missing, so that means that we can immediately rule out answer options B and C. So let's cross those off right now. And this comes in where we have the second rule, that actually black squares cannot touch each other. Now you might be thinking, well, does that include diagonal black squares? Well, in this example, it's quite ambiguous, so I would always say look to the example that they've given for some sort of precedent. In this case, you can see that already in the example, we've got these 2 black squares down here touching each other diagonally. So that suggests that diagonal touches are actually acceptable, and really all of the question is talking about is that we can't have horizontal or vertical touches. So with that understanding of the rules in mind, let's look at the answer options. Focusing first on answer option A, what's important to spot about this pattern is actually we see these 2 black corner squares right here. Now if you look at the space that this pattern is meant to fill, we have 2 black squares here which would immediately touch any black corner squares. Now the fact that these are diagonal and that these are vertical means that no matter how many times we rotate answer option A, it will always come into contact with one of these 2 black squares in the diagonal. So actually answer option A immediately we can tell isn't the right answer option. And you can test that by rotating it for yourself in your head or on your piece of paper, because remember BMAT is a paper exam, and that can help you spot that answer option A is not the answer option here. So that leaves us with D. We can check that, and actually immediately we find that it fits perfectly without any problems. We don't have to rotate it, it fits as it is perfectly within the pattern so that no black squares touch vertically or horizontally. So answer option D here is our answer. So our first tip of today is to avoid the common trap of not reading the question stem thoroughly enough. You saw in the previous example, there wasn't actually that much there. That's because the main skill, as I said, is manipulating and rotating things within your head. So whatever is there, really pay attention, because those set out the rules which help you to understand the question and help you to pick the correct answer option. So in the previous answer option, you saw that obviously we had the 30 square rule as well as the no black squares could touch each other rule. Those 2 rules are really pivotal to the question, so it's important that you read that within the question stem. Moving on to question 2 then. Read this one and have a go. Great, hopefully you've had a chance to have a go at that one for yourself. So there are 2 major ways that you can do this particular type of question. The first way, you can extend the pattern yourself. In this example, maybe do 3 rows of this sort of circular repeating pattern and then count up the number of shapes involved, and that will approximate the ratio if the pattern was repeated infinitely, as the question implies. The second way, and potentially quicker, is to look for a repeating motif, and that repeating motif will have the same ratio of shapes as the whole pattern when it's extended infinitely. So let's do both methods on this particular type of question. So reading it, we see that we have tulips, daffodils, and roses. So let's give each of those a colour. So tulips is going to be our yellow, Daffodils is going to be our green, and roses, fittingly, are red. So let's count the number of tulips first of all. We have 1, 2, 3, 4, 5, 6. However, in this case, the pattern doesn't really feel completed and we can't repeat this pattern infinitely. So it would make sense to fill in the gap. In other words, fill in this part here. So let's do that. 7, 8. Because you can imagine that those would form two separate circles. Okay, now let's move on to daffodils, marking down that there are 8 tulips. So daffodils are triangles. When we count those up and including the ones that are missing, in other words, there'll be one here, there'll be one here, and one here, we end up with 28 daffodils. Finally, when we do that with roses, we end up with 30 squares in the existing pattern, but remember, again, we're going to count those ones that are missing. So we have a square here, a square here, a square here, a square here, and a square here. That leaves us with a grand total of 35. So, with these numbers in mind, we can approximate the ratio. And actually, when we do this, it closely mimics answer option B, right over here. Now, this isn't perfect. Because we haven't repeated the pattern infinitely, our count will not be exactly right. So it's important to give yourself a bit of leeway. One way you can do that is by working out, well, if this pattern was repeated infinitely, is there anything that I've missed out? In this case, obviously if you repeated the pattern, you would eliminate this top row here. So if you counted up that top row, you could therefore get a phrase as to whether your estimate is too high or too low. But in this case, it's not necessarily needed because it approximates answer option B. Now the second way we can do it is look for that repeating motif. And this can be quite difficult because you've got to remember that this will be repeated infinitely, and that requires you giving yourself a bit of leeway considering that the pattern has to get going at the start. So if we assume that we only had this top row here with all these 4 circles, if you like, how then do we repeat the pattern? Well, you can see that actually, if I mark in blue, this sort of C shape here gets added on every time. And you can see it again, right here. That is the repeating motif. And as the pattern continues, this C shape will continue to add on to the pattern to extend it in each direction. You can see almost that we would get a potential C shape here as well as we add on the next pattern. So actually, if we add up the things within that C shape, we would find the ratio of shapes involved. In this case, we would have 1 hexagon, 4 squares, and 3 triangles. And that actually is the exact ratio in answer option B, which makes that one our correct answer here. Hopefully you got that. If not, don't worry. But remember, it's all about looking for those repeating patterns and repeating motifs. So you saw in that previous example that we could approach it from 2 major methods. The best, most successful way is to approach it by looking for a repeating motif. But if you can't find that repeating motif, or if you're not quite sure, it's just best to count up what you already have, maybe extend the pattern yourself manually for a bit, and then count up again and see what the pattern ratio is approximating. In other words, what is it getting closer to? In that way, you can help to estimate what the ratio should be based on your kind of rudimentary count. Okay, with that in mind, let's look at question 3 out of 5. Pause the video now and have a go. Okay, so let's go through this together. With this question, it's really important to be familiar with what the question is talking about. We see that he wants a variety of tiles, and let's highlight that right now. That means that he's going to use all of the answer options except for one. Now, it's our job to find that exception. So what are the rules that are involved? Well, he wants the same proportion of colours in his pattern overall. So that means that no matter whether it's 5 tiles or 10 tiles or 15 tiles, it's got to have the same proportion of each colours involved. So let's start by adding up the colours that we have and setting up a table. So I'm going to do that here in the space. We have three colours. We have pink, green and blue. Pink, green and blue. And we have 6 answer options. So let's mark that down. A, B, C, D, E and F. And we're going to have some totals at the end. So let's start with adding up how much pink tiles there are. In A, there are 4. In B, there are 3. In C, there are 2. In D, there are 2. In E, there are 3. And in F, there are 4. When we add those up, and a good tip for adding things up in the BMAT is to try and pair off numbers to make up to 10. So in this case, we could do 4 plus 4 plus 2, that's 10, plus 3 plus 2 plus 3, that's 18. So we can write that total down at the end. Let's do the same thing for green. So we have 3 in A, a total of 5 in B, a total of 4 in C. In D, there are 3. In E, there are 2. And finally, in F, there are 0. Adding that up again, we have 3 plus 5, that's 8, plus 4, that's 12, plus 3 plus 2, that's 17. Okay? Now, onto the blue squares. Let's do the same. So with answer option A, there are 2. With answer option B, there are 1. With answer option C, there are 3. With answer option D, there are 4. E, there are 4. And F, there's a total of 5. So when we add those up, 2 plus 1, that's 3. Plus 3, 6. 4 gives us 10. 4 plus 5, that's 19. So we can see that this particular pattern, when we add them all up, we get a mix of numbers. Now, when we exclude the pattern that's our answer option, we should end up with the same total of each of these colours right here at the end. So that means we've got to pick a pattern which levels out these differences. In other words, the pattern must have a lot of blue, followed by a lot of pink, followed by a lot of green. So it's a pattern which is predominantly blue, its second most common colour is pink, and the third most common colour is green. That will mean when we exclude it, they would all be taken down to the same level. So if we look through our answer options, the one which matches that perfectly is answer option E. We can see that there are 3 pinks in answer option E, there are 4 blue, and there are only 2 green. That means that when we take those away from the totals that we have, actually they all equal 15, and that's exactly what we need. Hopefully you can see how that works, and well done if you got that as the correct answer. So a really good top tip here is if you're running out of time in the BMAT, or you're finding a particular question quite difficult, is actually to rule out the impossible answers and take a guess at the remaining ones. In the previous example, answer option F wouldn't seem quite right because there's simply no green within that pattern. There's only pink and blue, so it doesn't make sense that that would be the one to level out those differences. So actually we can exclude answer option F, and immediately we've improved our chances of collecting the right answer just by guessing. So a top tip here, rule out the impossible answers where you can if you're running out of time. Let's move on. Pause the video now and have a go at this new question. Okay, so let's go through this one together. This is a classic BMAT question that will come up time and time again throughout the years if you look at the past papers. Now, it's a classic add them up and find the proportion of a particular colour. And immediately that seems quite easy. All we have to do is count the number of black squares, count the number of white squares, and then do 1 as a proportion of the total. But what this question is really testing, and what differentiates candidates, is how quickly you can do that. And the key time-saving technique here is to look for a repeating motif. Remember we said that about question 1 that we did? That's exactly the same here. We look for a repeating motif in this question. So hopefully you can see immediately what pops out is this 6 shape right here. And that's repeated. Now you might say though, actually it's not repeated quite fully because actually we have this end bit here that doesn't look quite like a 6. But if you look even closer, you can see that this end bit here actually continues here to give us the 6 shape. It's exactly the same vertically. This bottom of the 6 here has been shaved off, but look, it repeats up here. So actually this is a repeating motif and it's repeated as a whole number. In other words, we can have this repeating motif, which I'm about to highlight, and repeat it several times to give us this particular pattern. So that means that we can work out the proportion of black squares within that repeating motif, and that will closely estimate, in this case very closely estimate, it will give us the exact proportion of black squares in the whole entire pattern. So when we do that, we look at this particular yellow square that I've highlighted, and we can see that there are 14 black squares, and it's a 6 by 6 sort of square, so that gives us 36 total number of squares. Now this is the proportion that we're dealing with. You can go ahead and click that into your calculator right now if you haven't already to find out what the answer is. But remember, in the BMAT you won't have a calculator, so at this stage it's really important just to note that you will need good mental math skills, and if you can't already work out this fraction, then it might be worth going over your mental maths, going over your fractions, and trying to work out how you do these type of thing. In short, I would always sort of times by 10 and do 140 divided by 36, and then carry on doing that repeatedly, remembering that obviously you're a factor of 10 out. So when we do that all together, we get an answer of 39, and that's answer option D. So throughout the course of this tutorial, you would have heard me say repeatedly that there are repeats, rotations, and reflections within these questions. So actually you can memorize this by using 3 R's technique. Whenever you see a spatial reasoning pattern, remember the 3 R's. And actually that can help with 3D shapes, it can help with nets, and it can work with these patterns where we have the repeated motif. So top tip here is to remember your 3 R's when doing these type of questions. Okay, let's move on to our final question of today. Pause the video now and have a go at this question. Okay, let's go through this together. So remembering our rule about the 3 R's, repeats, rotations, and reflections, this question is all about rotations. Now, remember that we're looking for distinct patterns. How many distinct patterns are there? And we're told that we can rotate shapes, but we're not told that we can reflect shapes. In other words, we shouldn't assume that we can reflect shapes, so reflected shapes should be counted as distinct patterns. When I go through these questions, I like to go through them one by one, marking when I find a distinct pattern and marking when I find a repeated pattern. So let's go through. The first pattern over here is obviously distinct. Let's call that pattern number 1. That's repeated again in the second one, so I'm going to mark that pattern number 1. This third one is a distinct pattern. Let's call it pattern number 2. This fourth shape, pattern number 3, 4, 5. Now this looks similar to that pattern number 2, but you can see it's distinct. And the way I like to think about this is by looking at almost the displacement of the black squares involved. You can see here that the black squares are in pattern number 2 are on different sides, so maximal displacement in one direction, and they look to be about sort of sub-maximal, just one less than maximal in the other direction. In pattern number 5 though, this is not the case. They're maximal in one direction, but actually they're only one different in the other direction. That means that this is really clearly a distinct pattern, and we don't necessarily have to worry about rotating the shape in our head. Let's carry on. This is a distinct pattern here, so let's call that pattern number 6. This is also distinct, pattern number 7. Now that looks the same as pattern number 2, but looking at that maximal displacement again, you can see pattern number 2 is maximally displaced in one direction. The black squares are at opposite sides here. but in the horizontal direction, they're displaced by about 4, whereas in 7's case, you can see that they're maximally displaced in both directions. So we can call that pattern number 7. It's distinct. Moving on, this one looks very similar to pattern number 1, and this is where it's worth checking whether it's a rotation or a reflection. In fact, it's both. So actually, this isn't a distinct pattern, it's just the same as pattern number 1. Moving on, this pattern down here, that is distinct, so let's call that pattern number 8. Okay, it looks similar to pattern number 6, but another tip for these types of questions is pattern number 6, both of the squares are in the center. In other words, there's a nice white border all the way around, whereas pattern number 8 doesn't have this white border. That square there interrupts it. So actually this is a distinct pattern, we don't have to worry about rotating it in our head if we look at it through that lens. This next one here looks very similar to pattern number 2, and actually it matches what we said about the displacement. It's maximally displaced in one direction, but it's displaced by about 4 squares in the other direction. So it seems like a good candidate for being the same as pattern number 2. But if you rotate it, you can see actually it's not the same. The way I like to do this is that pattern number 2 has a black square in the corner, so let's put that black square of this pattern in the same corner by rotating it 90 degrees clockwise. Doing that, you can see that this square here would be brought down back into this position here. Whereas in pattern number 2, you can see that it's in this position here. So that position there is not the same as here, so this is a distinct pattern. So we can call it pattern number 9. Finally, moving on to the final option, it looks very similar to pattern number 6, but doing a rotational thing, we can see that actually it's a reflection and it's not a rotation. So this is pattern number 10. All in all, that means that we have 10 distinct patterns here, so the correct answer option here is D. So this last timing tip relates to the previous kind of couple of questions, and it involves if there's a repeating motif, you can just work with that repeating motif. And that's the biggest tip I can give you today, is remember that there's rotations, reflections, and repeating patterns. If you can spot any sort of repeats, that will always save you time because you can cut corners and work with the repeating motif. So that takes us to the end of today's lesson. Hopefully you fulfilled the learning objectives and now you can spot these spatial patterns using those 3 R's. We also shared with you some top tips about how you can save time and avoid distracting information and avoid those common traps such as not reading the questions then. And that's the lesson complete. Hopefully you enjoyed today's lesson. See you again soon. Bye.